in sequence and series, we are basically going to deal with two types of the series. So the first one we are going to deal with is that the arithmetic progression, and the second one is that geometric progression. So these are the two types of series we are going to deal with. Are you together? So let us start with the first one, the arithmetic progression. Now this kind of series uses the addition sign. Addition only. Are you together? Now first thing what you need to know about a sequence is just a set of numbers or a list of numbers following a particular order, isn't it? A sequence is just a list of numbers following a particular order. Like I can have a list of numbers 1, 2, 3, 4, 5, 6, 7. So I'm saying this is a sequence because it is following a particular order. In that I'm seeing there's a 1 adding to get the next term. 1 plus 1 I get 2, 2 plus 2 I get 3, 3 plus 1. No, 2 plus 1 I get 3, 3 plus 1 I get 4, 4 plus 1 I get 5. There's some common number adding there, isn't it? So there's a particular order. So when there's a particular order in that list, then we call it a sequence, isn't it? Then when we now talk about series or progression, it's now the sum of terms of the sequence. Are you seeing that? Meaning sum of terms of the sequence, meaning if you sum these terms now, it now becomes a series or a progression. So it means when we are talking about a series or a progression, when we are talking about a sequence or a series, it doesn't matter whether we are in a series or a sequence, the term will remain a term. If you are in a sequence like this, 1, 2, 3, 4, 5, that's a sequence because it is a list of numbers following a particular order, isn't it? So you can see 1 is your first term, 2 is your second term, 3 is your third term, 4 is your fourth term, in that order, isn't it? So in the sequence, if 1 is the first term, it will lose the first term. So if you make this sequence a series, it is just by summing up these terms to make it a series, isn't it? So whether it is in a series, the first term number 1 will still remain the first term there, isn't it? So it means a term will remain where it is, whether it is in a sequence or in a series. So when I talk about the first term in a geometric progression or in arithmetic progression, those terms arithmetic or geometric are just the particular order defined in that sequence, isn't it? But now when I now talk about a term of a given progression, because a progression is a series, isn't it? When I talk about seventh term of a series means that it is the sum of the terms. Whether you are adding them, the seventh term will just occupy that is position number 7, isn't it? Whether it is in a sequence, the seventh term will just occupy that position number 7, isn't it? So it doesn't matter whether they say the second term in arithmetic sequence or the second term in arithmetic series. In the series or in a sequence, the second term remains the second term. Are you getting the idea? Whether it is in a series or a sequence. Are we together there? Now, when we are now dealing with the arithmetic series or the arithmetic progression, we start by checking on the arithmetic sequence. So the first thing you need to know about the arithmetic progression, just as I said, it uses that addition sign only. What does that imply? This is what it implies. When you have this sequence following this particular order, 1, 2, 3, 4, 5, 6, 7. Here you can see you add 1 to get the next term. When you add 1, you get the next term. You add your 1, you get the next term. You add your 1, you get the next term. You add your 1, meaning that there's a common number you are adding to get the preceding term, isn't it? Are we together? So if you look at this, when you now have another series like this, 5, 4, 3, 2, 1, you cannot come here and say, at 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 4, then you say at 1, because you see you are now using subtraction, are you seeing? But you see this series uses what? Meaning, what do I add to 5 to get 4? Meaning 5 plus negative 1 gives me 4. Are you seeing what I'm talking about? Then 4 plus negative 1 gives me 3. Are you seeing that? Then 3 plus negative 1 gives me 4. Meaning, this series uses addition sign. Are you getting that? Yes. So it means when it is decreasing, it means you are adding a negative number. That is why it is decreasing. So you cannot say 5 minus 1 to give it 4, because it does not use subtraction. Are you seeing that? Are you getting the idea? Are we together? It basically uses the addition sign only. So when you are getting this common difference between the two numbers, it is addition sign only. So after that, what else do you know about arithmetic series? The first term is denoted by A. So the first term is denoted by A. Then the next thing you will need to know about arithmetic series or progression, the difference between any two consecutive numbers. Consecutive numbers means the numbers is not consecutive numbers, consecutive terms, isn't it? So the difference between any two consecutive terms is always denoted by D, isn't it? Referred to as the common difference. Two consecutive terms means the terms which follow each other, isn't it? You see that? So the difference, and when you are getting a difference between anything, so it is always the second minus the first, or final minus initial. So that is how you get the difference between something. So that when it is final minus initial and you get the difference to be negative, then you say the difference is a decrease, isn't it? Then when it is final minus initial, you get the difference to be positive, then you can see the difference is an increase, isn't it? The difference is always the final value minus the initial value, meaning the second term minus the preceding, isn't it? So the difference between any two consecutive terms is denoted by D, referred to as the common difference. Referred to as the common difference. So anytime we are getting the difference between any two consecutive terms, we denote it by a D, and it is referred to as the common difference. So now we've known that this progression uses addition sign, and we've known that the first term is denoted by A, and we've known that the common difference is denoted by D, meaning we can use this information to construct this kind of series, isn't it? So let us now see, for us to construct, we must have the terms. For instance, some few terms. First term, second term, third term, fourth term, fifth term, in that order, isn't it? So the first term we've said is denoted by A. Then we see for us to get the second term, we've said this series uses what sign? Addition sign. So this addition, you add the difference between them, isn't it? Meaning A plus D, you get the second term. A plus, it specifically uses what? Addition. Then for me to get the third term, because between the two consecutive terms, it will be A plus D, then plus your common difference between the two terms, isn't it? So A plus D, what do you get? A plus, are we together? Then from there, if you add your common difference between these two numbers, A plus 2D plus D, you get the next number, isn't it? Specifically addition, meaning you must add it, isn't it? So A plus 2D plus D, see that is 2D plus D, you get 3D, isn't it? So you have A plus 3D. Then for you to get the next term, you have plus 3D, A plus 3D plus D, you get A plus 4D. Now, if you look at that, you are able to see, when you are dealing about the fourth term, it is 3D. When you are talking about the fifth term, it is 4D. When you are talking about the third term, it is 2D. So that implies the conclusion you can make when you are talking about the nth term, it will now be A plus n minus 1 into D. Because when n is 4, I'm talking about the fourth term, isn't it? When n is 4, I'm talking about the fourth term. And when I'm talking about the fourth term, it will be 4 minus 1. I get my 3D, isn't it? Are we together? When I'm talking about the 10th term will be A plus 10 minus 1, 9D. Are you seeing that? Are we together? Yes. So it means for you to get the nth term of an arithmetic progression, it is A plus n minus 1 into D. Are we together? Now it means what you need to know in arithmetic progression, how do I denote the first term? How do I get the common difference between the two terms? And you see, to get the difference is addition sign specifically, isn't it? Then from that association, you are able to get the formula for getting any term in arithmetic progression or sequence, because a term number will remain a term number whether it is in a series or a sequence, isn't it? Are we together? Now after that, we now want to see now we see this is now just a case of an arithmetic. This is a case of an arithmetic series because they are just term, first term, second term, third term, fourth term. Now in case of an arithmetic progression, we are going to sum the terms, isn't it? Are we together? Now what about when we now sum the terms to form a progression, isn't it? The sum of the terms of a sequence, isn't it? Can we now sum these terms to form a progression? So the sum of the n terms here, meaning we've already found here, look at this. We found that the first term is a, the second term there we've seen is a plus b, the third term there we've seen is a plus 2d, meaning the nth term we found to be the last term, isn't it? Have you seen that? The last term we found is a plus n minus 1 into b, isn't it? Are we together? So it means when I want to sum all these terms, what am I going to do? I'm going to denote the sum of the n terms of an arithmetic progression, the sum of n terms of an arithmetic, the sum of n terms of an arithmetic progression is denoted by, the sum of n terms of an arithmetic progression is denoted by s subscript n. Are you seeing that? Meaning when you want to sum the terms of an arithmetic progression, no, it is a progression because you are summing the terms of the arithmetic sequence to make it a progression, isn't it? So the sum of any n terms of that given progression is denoted by Sn. So can I now sum the n terms of this progression? Sn is what? So it will be the first term, which is a plus the second term, which is a plus b plus the third term plus up to the nth term, which is the last term, that, isn't it? Are we together? Yes. Is that okay? Yes. Now look at that. So look at this. Now what about if I change it so that I start with what is in the end there and this one x the other side? When I swap it, when you swap it, you still get your sum of n terms. Now instead of starting with the first term, I want to start with the last one. It's like saying when I have 1 plus 2 plus 3 plus 4. See, I can as well start from 4 coming this side. 4 plus 3 plus 2 plus 1, isn't it? Yes. So what about when I swap the order, I start with the last one? I will have a plus n minus 1 into d, then plus. Remember, it means the one which is here will be what? A plus n minus 2 into d. Because if this is n minus 1, it means this was n minus 2, isn't it? Isn't it? Then plus. Then what will end here will be this first term, isn't it? Are you seeing what is happening? What will end here will not be the first term. So you see here, what if I now add the two? The first one, I've gone direct, the second one, I've started with the last one, then I now want to add the two, isn't it? So can we now add the two? When I add the two, Sn plus Sn, I get 2Sn. Then you can see, here, A plus, that, what do you get? A plus this, you get A plus A is 2A. Then n minus 1d remains that, isn't it? Yes. See there? See, A plus A is 2A. Yes. So that one you get 2A plus n minus 1d, because there is no n minus 1d there, you are done with that, isn't it? Then plus A is 2A. Then here you now have d. Look here, when you take d inside this bracket, it is d times n, d times negative 2. So you get minus 2d. So minus 2d plus d, see that is minus d. See, it means we will remain with n minus 1 into d. Because 1d has cancelled with this positive d. Are you see? Because here you have a plus n minus 2 into d, then plus a plus d. A plus a is 2a, isn't it? Then plus n minus 1 into d. Because here d times 2 is 2d, then minus 2d and positive 2d is remain with minus d. And yes, you see it is minus d. Are you seeing you are getting the same thing as this? Are you seeing that? Yes. You are getting the same thing as this, which is 2a plus n minus 1d. Then plus, and the last one is what? A plus a, so you still get the same thing. Are you seeing that? you still get the same thing, which is 2a plus n minus 1 into d. So you see, this side we have 2sn to be equals to what? You are getting the same term how many times? N times, because the last term was the nth term. The nth term, isn't it?
Yes.
The sum of the n terms, meaning there are n terms. So if you are summing the same thing n times, see, it's like you are multiplying that thing with n. Meaning when I'm summing 2 plus 2 plus 2 plus 2 4 times, see, it's like I'm multiplying 2 times 4. So here it means I'm summing the same factor. You see, this is the same factor n times, because this was n times, isn't it? Meaning I'm going to get n times that same factor, 2a plus n minus 1 into d, isn't it? Are we together? So it means for me now to get Sn, I have to divide both sides by 2. Then I get the sum of n terms of an arithmetic progression is given by n over 2 into 2a plus n minus 1 into d. Are we together? So it means that is how to get, if you want to get the sum of the n terms of an arithmetic progression, then it is given by n over 2 in bracket 2a plus n minus 1 into d. Are we together there? Now after that, something you've also noted that the last term is the nth term, isn't it? The last term is that nth term. So this nth term is the last term. So it will simply imply that the last term L is a plus n minus 1d. The last term is the nth term. And if the nth term is given by a plus n minus 1d, then it means it is the L which is denoting the last term, isn't it? So if you denote the last term with L, it means L is equals to the nth term. So it means here, what will be the sum of n terms? What will you have to be the sum of n terms from here? Because we are saying the last term is the n term. Remember, this is 2a. Are you seeing that? So, if this is 2a, then it means 2a is as well the same as saying a plus a, isn't it? So that a plus n minus 1 into d, the whole of this is L. Are you seeing that? The whole of that is L. So it is like saying, that is your n term. So it is like saying this one is equals to n over 2 into this a plus the whole of this is the L. Are you seeing? Because this was a plus a is 2a. So it means this a plus n minus 1 is the nth term, which is the same as L. So we have a plus L. Are you seeing that? So it means the sum of n terms of an arithmetic progression is given by n over 2 into 2a plus n minus 1 into d, which is the same as a plus L inside the bracket, because L is the nth term. Are you getting that? Are we together? It's the last term. So it means when you know all this in arithmetic progression, then you can handle any problem which involves an arithmetic progression. In arithmetic progression, you should know it is specifically using the addition sign. In arithmetic progression, you should know the first term is denoted by A. In arithmetic progression, you should know the common difference between any two consecutive terms is denoted by B. And in arithmetic progression, you should know the nth term is given by the first term plus n minus 1 into d, isn't it? And in arithmetic progression, you should actually know that the sum of the n terms of an arithmetic progression is given by n over 2 in bracket a plus the last term, isn't it? Or n over 2 in bracket 2a plus n minus 1 into d, isn't it? Then, when you know all that, then it means you will never have any problem involving this kind of progression, the arithmetic progression. Are we together? Can we now see the second kind of progression, that is the geometric progression? How do we deal with a case of a geometric progression? How do we deal with the case of a geometric number 2, geometric progression. Now, geometric progression specifically uses the multiplication sign. Are we together? Geometric progression, unlike the arithmetic progression, geometric progression specifically uses a multiplication sign, meaning there's nothing like a division sign here, you see. So that is why I'm saying, so when you have a geometric sequence, like when you have a case like a number like 1, 2, 4, 8, you can see 1 times 2 gives you 2. Are you seeing? 2 times 2 gives you 4. 4 times 2 gives you, meaning there's a common ratio between any two consecutive terms, isn't it? So you cannot say, when you have something like 8, 4, 2, 1, you cannot say 8 divided by 2 gives you 4. You cannot say 4 divided by 2 gives you 2. You cannot say 2 divided by 2 gives you 1. Because this sequence specifically uses a multiplication sign, meaning it is 8 times a half gives you 4. Are you seeing that? You can see it is 4 times a half gives you 2. 2 times a half gives you, specifically uses a multiplication sign. Are we together? So for you to get this common ratio between any two consecutive terms, then it is multiplication sign. And for you to get a common ratio, it is the second over the first, isn't it? We'll see how that is coming about. So let us start in geometric progression. So you say it specifically uses a multiplication sign. Then as usual, the first term is denoted by A. So the first term of a geometric progression is denoted by A. Then after that you say there is a common, yes, there is a common ratio between any two consecutive terms denoted by, there's a common ratio between any two consecutive terms denoted by R. Are we together? So once we've known that this series specifically uses multiplication sign, the first term is denoted by A, and there's a common ratio between any two consecutive terms, then we can construct this kind of series, isn't it? We just use some few terms, even 4 terms. So we use some few terms, the first term, the second term, the third term, the fourth term. Those few terms are enough to construct, isn't it? And we've said the first term is denoted by what? By A, isn't it? Meaning for us to get the next term, we've said this progression specifically uses multiplication. Meaning if I multiply A with the common ratio, I get the next term. Are you seeing that? Then I go to the next AR. If I multiply with the common ratio, I get the next AR squared. Because AR times R, it means we have R times R. So that is R squared. Are we together? To go to the next term, AR squared, if I multiply by my common ratio R squared times R, you're going to get R cubed. So we are going to have AR. Are we together? So from here you can see, when it is the fourth term, it is raised to power 3. When it is the third term, it is raised to power 2. So that was the implication. The implication is that when it is the nth term, it is now AR raised to power n minus 1, isn't it? Because if the nth term is 4, if n is 4, meaning we are talking about the fourth term, now this n, if you put for 4 minus 1, R raised to power 3. Are you seeing that? Are we together? So it means the nth term of a geometric progression is given by AR n minus 1. So you can see the reason why I'm driving how these things coming about, so that you can see the easier way of mastering a formula, isn't it? Are we together? So that when you are in such a kind of situation, you can easily recall the formula by just using some few terms to do the construction, knowing that it specifically uses multiplication sign, the first term is A, the common ratio is R. Then with all those 3 facts, you are able to construct the sequence, isn't it? Then from the sequence you can see the set of rule or the formula for getting the nth term, isn't it? How do I now get the fourth term? How do I now get the 17th term? How do I now get this, isn't it? Now after getting nth term, now we are now talking about a case of the sum of n terms of a geometric progression. So the sum of n terms, the sum of n terms of a geometric progression is denoted by Sn. Just like arithmetics, you know, take the sum of n terms is S subscript n, isn't it? So can I now sum n terms of a geometric progression? The first term is A, then plus, the second term is AR, isn't it? Then plus, the third term is AR squared, then plus up to the last term, the nth term is AR n minus, isn't it? N minus 1, like that. Are we together? So, look at the next one. Now, what if, because, you see, when I multiply both sides of the equation with R, I will get what? Let me add the two terms in the end there for you to see it clearly. You don't need to wrap that. The sum of n term is A plus AR squared plus. Then the second last term will be AR n minus 2, isn't it? Then the last term, as we've seen there, is now AR n minus. The last term is AR n minus 1, isn't it? Are we together? So, you can see, when I multiply both sides of this equation by R, I will still be getting AR squared, AR cubed, up to that, are you see? So I can decide to multiply both sides of the equation by R, isn't it? So that when I have this side R times Sn, I get Rs, then R times A, see that is AR. See there? Then R times AR, so you get the AR squared. R times AR squared, so you get AR. Then plus R times AR raised by n minus 2. So you get AR n minus 1. Because R n minus 2 times R. See the same base with multiplication sign, you add the powers. See n minus 2 plus 1, you get n minus 1. So you get that. Are we together? Then plus R times AR n minus 1, you get AR to power n. Because AR n minus 1 times R is raised to power 1. So here you have your A is there, then you join this. R times R, same base, you add the powers, isn't it? N minus 1 plus 1, you get? Are you see that? Yes. Now look at this. Look at this too. So you can see, from this term, AR up to AR n minus 1 is the same as here. From here, AR up to AR n minus 1, meaning this is the same as this. Are you seeing? Are you seeing what is happening? Yes. So it means the moment you subtract the two equations, this is going to subtract this is going to go to 0. Are you seeing that? Are you seeing that? So when I subtract the two equations, Sn minus Rsn, see that is Sn minus Rsn. I'm done with the left hand side of the equation, isn't it? Then on the right hand side of the equation, when I subtract this bracket minus this bracket, it goes to 0, isn't it? Meaning what I will remain with in the numerator is A minus that, isn't it? I will remain with A minus AR, isn't it? Because the whole of this bracket disappears with this bracket when I'm subtracting. So in the numerator, I just remain with A minus AR to the power n, isn't it? Are we together? So from here you can see, on the left hand side of the equation, Sn is a common factor, isn't it? So you can factorize out a common factor. If you factorize out a common factor here, you remain with a coefficient of 1 minus a coefficient of R, isn't it? Then on the other side, you can see A is a common factor. If you factorize out a common factor outside the bracket, the coefficient here you remain with 1, the coefficient here you remain with minus Rn. Are you seeing? So if you make A Sn the subject of the formula, you divide both sides with 1 minus. So what will you get? You will get the sum of the n terms of a geometric progression to be given by A into 1 minus Rn over 1 minus R. Are you seeing that? Or, at the same time, if you took this second equation minus the first equation, it means this bracket is now going to change, isn't it? Are you see that?
Yes.
It is like you're now going to have Sn is now going to be a Rn minus 1 over R minus 1. Are you seeing? So that is what is going to happen. Meaning if you remove negative outside the bracket, when you factorize out negative here and you factorize out negative here, negative will cancel out to the negative, then this one will now start, isn't it? So this is why when you go to the table, here they will tell you this is good to use when the absolute value of R is less than 1, because 1 minus that, you get is easier to work with. Then here they will tell you when the absolute value of R is greater than 1. Remember, you can use that one. They are just telling you to avoid getting very many decimal places. But whether you don't deal with the absolute value of R being what, whether you use this formula or this, you will get the same answer. It's only that if this first formula was giving you the sum of n terms, maybe to be 100 over 10, the second formula will give you the sum of n terms to be negative 100 over negative 10. At the end, you will all get the same answer. Are you seeing? Meaning they are trying to tell you that you can use either this or this, because they are trying to tell you that when the absolute value of R is less than 1, it is easier to use this. When the absolute value of R is greater than 1, it is easier to use this. But you can use any. Well, the reason why they are telling you it is easier to use this or this is because they are trying to avoid a case whereby you will end up with a lot of negatives when you simplify, isn't it? But you know, in your case, you don't need to bother yourself whether you'll be ending with a negative or not. You need to know that you are going to get the answer at the end. Are you getting that? Are we together in what I'm saying?
Yes.
So, coming here and going to the log table and start struggling which one do I use, that is not important. What is important is that once you master any one of them, even only this one, you are done. You can use anything there. Are we together? Forget about that idea of absolute value of R being less than 1 or being greater than 1 to use this. Those are just ways to show you that it is easier to use this formula to get the answer fast. Are you seeing that? But at the end, you will get the same answer by using any of them. Are you seeing that? Are we together? And remember, when you work out this problem and you get R to be negative a half, so that when you go to the formula and you are saying at the absolute value of R should be less than 1, then you are now saying the absolute value of negative a half should now be half. No, that is not what is meant by absolute value of R being less than 1. What this means is this: when absolute value of R is less than 1, what it means, you don't make noise when you come late. When absolute value of R being less than 1, it simply means R is less than plus or minus 1, because that absolute value is plus or minus. Are you see? Meaning they are trying to tell you when the value of R is between the range of negative 1 to 1. When you can see negative half is between such kind of range. Are we together? So R value will remain R value. Even if it is negative because it is within that range. Absolute value does not mean that you ignore the sign of R. That is R. That is just showing you the range. That is the range from this negative number to this positive number. Are you getting that? But R is R. Whether you get your R to be negative R or you get your R to be positive R, it is that R. You cannot ignore a sign because that negative is part of R, isn't it? Are we together? So that has nothing to do with the definition of those formulas. So let us not be misguided on how to interpret a formula from the log table. Okay? You don't be misguided. Now, you now see the sum of infinite terms in the same log table when n is infinity is given by what? A over 1 minus R when n is infinity, isn't it? It is given by A over 1 minus R. And all these formula, you know, log table is one of the requirements in that. One of the requirements in that exam room. How are they getting A over 1 minus L to be the sum of infinity? This is how they are getting it. This very simple concept. When you have sum of the n terms to infinity, let us say, for instance, you have the first term is A, the second term plus the second term plus the third term A squared, A cubed, A to power 4 plus. Are you seeing that? See, infinity means it is not coming to an end, isn't it? See, this is now the case of an arithmetic progression where the first term is A and the common ratio is R. See, this will be the first term, second term, third term, fourth term, fifth term, and that one up to infinity, isn't it? Are we together? So if you look at this, if you factorize out A is a common factor, what will you remain with this side? 1 plus R squared plus r cubed plus r to the power 4 plus up to the n. Then you now ask yourself, what is that series? That is which series is that? That is a binomial series. That is a binomial series. It is a binomial series which is the same as 1 over 1 minus r. Because if you have this binomial series 1 over 1 minus r, it means it is 1 over r raised to negative 1. Negative means it is in the numerator reciprocal, isn't it? So in this binomial series, when you have a binomial series 1 plus x raised to power n, what does that mean? It is the first term is 1 plus nx, first and second term, isn't it? Third term is always 2 factorial, then 2 terms in the numerator, n into n minus 1, then x is squared. That was the Maclaurin's expansion of the binomial expansion, isn't it? Then the next term will be when it is 3 factorial, 3 terms in the numerator, n minus 2, then your x is cubed. Now you can see our problem here is 1 minus r raised to negative 1. Meaning they're trying to say where there is x, you put negative r, where there is n, you put negative 1. Are you seeing that? Where there is n, you put negative 1, where there is x, you put negative r. So you see 1 here, plus n times x. You see, n is negative 1, x is negative r. So n times x, negative 1 times r, negative r. So that is r. See, negative times negative is positive. Then you go here, n into n minus 1. n is negative 1, then negative 1 minus 1 is negative 2, isn't it? Over 2 factorial. Negative 1 times negative 2 is 2. 2 divided by 2 factorial is what? Is 1. Then you remain with x squared, and x is negative r, so you remain with the negative r squared. Negative squared is positive, r squared is r squared. You see what is happening? Then you move to the next one. You move to the next one. This one, n into n minus 1 into n minus 2. n is negative 1, isn't it? So you have negative 1, then negative 1 minus 1 is negative 2. Then negative 2 minus, then negative 1 minus 2 is negative 3. Over what? Over 3 factorial. Then your x is cubed. X is negative r cubed. So you see, negative 1 times negative 2 times negative 3, you get negative 6, isn't it? So negative 6 divided by 3 factorial, because 3 factorial is 6. The negative 6 divided by 6 is negative 1. So then negative cubes in the negative. Then r cubes in the r cube. Negative times negative is positive. So you remain with plus r cube, plus, plus, plus. So if you look at this, what is this? 1 plus r squared plus r cubed in that order. So you can see it is the same as this. Are you seeing that? Yes. So it means the whole of this is the same as, the whole of that is the same as a into, because the whole of this we found is the same as this. It's the same as 1 minus r raised to negative 1. Meaning it is a over 1 minus r. This is what you have there. You see how this is coming about? The binomial series. That Maclaurin's expansion of the binomial series. Then you get the infinite geometric series. The sum of n terms of an infinite geometric series is resulting from the Maclaurin's expansion of the binomial expansion. So that is the end of the geometric progression. So from geometric progression, you see that the first term is a. The common ratio is denoted by r. You've seen the nth term. The nth term is given by ar n minus 1. Then you've seen the sum of n terms is given by a into r raised to power n minus 1 over r minus 1. Or you can as well say it is a into 1 minus r raised to power n over 1 minus r. At the same time, you've seen the sum of the infinite number of terms in a geometric progression is just given by a over 1 minus, and you've seen that is resulting from the Maclaurin's expansion of that, the Maclaurin series expansion of the binomial expansion. And that is the end of sequence and series. Now we want to see cases of sequence and series where it will be either arithmetic or geometric and their applications, isn't it? Good. So that is the full lesson on sequence.